All right, so I think I'm recording. Let's take a look at this problem. It's a problem on uniform motion. Two trains start from the same station at the same time and run in opposite directions. One runs at an average rate of 40 miles per hour and the other 65 miles per hour. And how many hours will they be 315 miles apart? So let's draw a sketch. So here's the station. And here's one train. Okay, it's not a very good looking train, but here is another train. All right, so they started this at this station at the same time. Let's call this one train A and this one train B just to distinguish between them. You can think of your own names. One runs at a rate. So let's come over here, and the rate of train A is, say, 40 miles per hour. And the rate of train B looks to be 65 miles per hour. And at some point, they are (315 miles apart. Okay, so if the distance of train B is x, then the distance of train A is 315 minus x. All right, so well, what we could do, we know that they left at the same time and they traveled for the same length of time. So I know that the time that train A was on the tracks running is the same as the length of time that train B was moving on the tracks. And I know that my relationship in uniform motion problems is distance is equal to rate times time. So that tells me that time is distance divided by rate. So the distance of train A divided by the rate of train A is the same as the distance. That ratio will be the same ratio as the distance that train B travels divided by the rate of B. And we can then figure out through the distance how long it will take for them to be 315 miles apart. This is one way that we can do it. I'll show you another way after we get this one done. All right, so the distance for train A we said was 315 minus x. The rate is 40, and over here the distance of train B traveled is x, and that's 65. So if this is a proportion, so if we solve this proportion by cross multiplying, we'll have 40 times x is equal to 65 times 315 minus x. That'll give us 40x is equal to, I do not know what 65 times 315 is. My calculator is telling me 20,475. Hopefully I punched that in right. And if I add 65 to each side, I'm getting the x is 195. So if I if I return to the right hand side of this, because x was the distance for train B, if I figure out, now this t is not for train, this t is for time. The time that train B was traveling, which is the same as train A, is 195 divided by 65. And I'm getting 3. So it will take 3 hours under these conditions for these two trains to be 315 miles apart. So there's our final answer. Now, what if I had solved this in a different way? Let's think about this. So say that we came in and said that the time t for train B, let's just let it be t, it's unknown. Well, the time the time B is equal to also the t. We know that they've been traveling the same amount. But instead of setting the two times equal to each other, what if I looked at it as the total distance that the trains have traveled is the distance that train A has traveled plus the distance that train B has traveled. And they have told me that total distance was 315 miles. And I know that distance is rate times time. So the distance of train A is the rate of A times the length of time that train A was on the tracks. And the distance that train B traveled is the rate that train B is traveling at times the length of time that train B was on the tracks. So the rate of train A is 40 miles per hour. And T, we said that T was the unknown, that T was the length of time that over, why did I call both of these B? Sorry about that. Isn't this train A over here? All right. The other train traveling at 65 miles per hour, it was also on the tracks for that same length of time. So 315 is equal to 105 times t. And so 315 divided by 105 should be 3. Yep. So two different ways to get the same answer. While the second way is more direct because we let the unknown be t, you have to think not in terms of what am I equating the time or the distance. You have to think, how am I breaking up the total? And for when you break up a total, there can be no overlap. You know, they both started at the same place. So that's important if you decide to try to use that method, that the sum of the parts is equal to the total, that means that there's no overlap, that they both started from the same station. So hey, I hope that helps, and I will talk to you later. Bye.